Find the derivative of y equals 3x minus 2 over the square root of x times x minus 1, then evaluate y prime of 4. Y here is made up of the quotient of two functions, 3x minus 2 divided by the square root of x, and the product times x minus 1. One option is to use the quotient and product rule together. Another option is to take the product directly by putting that x minus 1 over a 1. We can now multiply the numerators, 3x minus 2 times x minus 1, over multiply the denominators, the square root of x times 1, which is the square root of x. I can FOIL out the numerator. First, 3x times x, 3x squared. Outside, 3x times a negative 1, negative 3x. Inside, negative 2 times an x, negative 2x. And last, negative 2 times a negative 1, positive 2. All of this over the square root of x. We can combine together the second and third terms in the numerator, and that will give us a 3x squared minus a 5x plus 2, all divided by the square root of x. We still have a quotient. One option is the quotient rule from here, but if you have a single denominator term, it's not added or subtracted with anything else, we can avoid the quotient rule by taking the quotient directly, put each of the terms in the numerator over that single denominator. So we can now write this as 3x squared over the square root of x minus 5x over the square root of x plus 2 over the square root of x. The x's in the first and second fractions can be combined by rewriting the square root of x as x to the 1/2 and then subtracting the exponents. The third term we're going to also write as x to the 1/2. There's no x in the numerator to cancel with, but the x in the denominator can move to the numerator. Square root of x to the first power is x to the 1/2. I'm going to rename each of these as x to the 1/2. The first one, we can combine the x's by subtraction due to division. 2 minus 1/2. The second term, the same thing, by subtraction, x to the first power, subtracting the 1/2 due to the division of x's. And then the last term, I can bring that x to the numerator. There's not another x to add the exponent with, so it'll just be x to the negative 1/2 when you move it to the numerator. The next step is to get a common denominator to add those fractions together. So y is going to equal 3x. We're going to multiply that 2 by 2 over 2, so that'll be 4 over 2 minus 1 over 2 minus 5x. We'll multiply that 1 by 2 over 2 to give us 2 over 2 minus 1 over 2. And I'll leave the last term alone since that one is good the way it is. We have no x's to combine. So we have 3x to the 4/2 minus 1/2, 3/2, minus 5x to the 2/2 minus 1/2, which is 1/2, and then plus 2x to the negative 1/2. Each of these terms will require a power rule for their derivative. We can now do that. Y prime will be 3 times, bring the power down, 3/2, x raised to the 3/2 subtract 1, I will call it 2/2 so I can subtract it from the fraction, minus 5 times, bring the power down, 1/2, x raised to the 1/2 minus 1, which I will call 2/2, and then plus 2 times, bring the negative 1/2 down, and then subtract 1 from the negative 1/2. Let's call it 2 over 2 So the common denominator is there for those. Now let's combine the fractions together for the exponents and the coefficients. Let's multiply those fractions. We can think of the 3 as 3 over 1, the negative 5 is negative 5 over 1, the 2 is 2 over 1, to be able to make the multiplication a little bit easier. 3 over 1 times 3 over 2, multiply the numerators. 3 times 3 is 9, 1 times 2, so the denominator is 2, 9 halves. X raised to the 3 halves minus 2 halves is 1 half. We have a negative 5 times a 1, which is negative 5, over 1 times 2, which is a 2. X to the 1 half minus 2 halves, negative 1 half. And then we have a 2 over 1 times a negative 1 over 2. 2 times negative 1 is negative 2. 1 times 2 is 2. Negative 2 over 2, or just negative 1. And then x to the negative 1 half minus 2 halves, minus 1 minus 2 is minus 3 halves. There's a couple of negative exponents in here. We'll want to rewrite those into a denominator. So y prime can be written as 9 halves. That first one, x to the positive 1 half, x to the first power, and then the 2 in the exponent, the denominator of the fractional exponent, is the root, the square root of x to the first power, or just the square root of x. We have a minus 5 over 2. Let's move that negative 1 half to the denominator and call it positive 1 half. And then we have a minus, we'll leave a 1 behind, we'll move that x to the negative 3 halves to the denominator, call it x to the positive 3 halves. So we have 9 halves square root of x minus 5 over 2. X to the 1 half, again, is the square root of x to the first power, so square root of x. And then x to the 3 halves is the square root of x cubed, or you can just keep it as x to the 3 halves. That's how it's commonly written, as x to the 3 halves. And there is our derivative. Now we're going to evaluate y prime of 4, so we're going to plug a 4 into each of those x's. That will give us a 9 over 2 times the square root of 4 minus a 5 over 2 times the square root of 4 minus 1 over 4 to the 3 halves power. The square root of 4 is a 2. Likewise, in the denominator of the second fraction, square root of 4 is a 2. And then 4 to the 3 halves, that means to take the square root of 4, which is a 2, and then cube it. So we'll have just a 2 cubed down there. Now that first fraction, we can write that as 2 over 1 if we'd like, and the 2's can cancel since they're multiplying, and therefore we get a 9 over 1, or just a 9. The second fraction will be negative 5 over 2 times 2, which is 4, and then the third fraction is going to be negative 1 over 2 cubed, or negative 1 over 8. We're going to want to combine all these together with a common denominator. That's going to be our next step. Let's get a common denominator with each of them. We can write that 9 as a 9 over 1, if it helps us. Common denominator is going to be an 8, because 8 is divisible by 4. So I'm going to multiply that first fraction by 8 over 8. 9 over 1 times 8 over 8. That second fraction by a 2 over 2. And that third fraction, I'm just going to leave the way it is. It's already over an 8. So y prime of 4 is going to equal the first fraction, 9 times 8 is 72, over 1 times 8, which is 8. The second fraction, negative 5 times a 2, is a negative 10, over a 4 times a 2, which is 8. And then we have minus 1 over 8. We can now combine these over the common denominator. It's 72 minus 10 minus 1 all over 8. 72 minus 10 is 62, minus 1 more is 61 over 8.